Hello, digital electronics. We're going to take a closer look at the 2.1.1 activity, the 3 sensor alarm light, temperature, humidity, particle density sensors. First thing we do is make a truth table for when the alarm will trigger. And then from there, you make the truth table. And from there, you find the sum of products logic expression. And the logic expression that you fill in on your activity, you would put down here. I'm going to put it right here for reference, so we could always reference it, right? On a new Multisim sheet, if you need a new paper size, you go to right-click Properties, Workspace. You could change it from letter A, which is smaller, to letter C, a little bigger. Hit OK. Get a little more workspace. Okay. So the best way to build a Multisim logic circuit from your logic expression is just to use these buttons from left to right. So play source. Just always need a VCC up top. And you always need a digital ground, DGND. Put that like this. Okay, then you're going to need 3 basic switches to represent TH and F. F is the air sensor, the air particle density sensor. So I did not click correctly. Basic switch, SPDT. Just lay 3 of these out right away. 1, 2, 3. Close. I like to counterclockwise rotate these. I like to double click. Make the far left one T for temperature sensor. Make the middle one H for humidity sensor. And then per our logic expression, the third one on the right, it's going to be F for air particle sensor. So each switch has a left and right pole. The left pole on each switch should connect to hot, 5 volts. The right part of each switch should connect to digital ground. I know this is pretty tight, but it's all good. Okay? A mouse could help you out a lot. What I like to do at the bottom is I like to put 6 probes upside down. So indicator probe, let's just use yellow. Or line eye orange, here we go. Ranked football team for once, here we go. Just lay out 3 right next to each other. So we're going to be efficient in this. We want to be as efficient as possible. And then what we're going to do is we're going to copy these, Control C, Control V, put them right next to each other. Oh. Then we're going to highlight these and flip vertically. Okay. TTL. I think we need 3 inverters here. Let's see. 4. Physically, we have N in the classroom. Let's put A gate here, B gate here, C gate here. So we're using 3 inverters from the same U1 inverter chip. Okay. Positive T goes all the way down. So we need to create a negative or not T bus line, which is this one. Positive H. not positive H, or not H. So we're creating like our bus lines where to pull from. All right, if you need more room, you could highlight these and pull these down. So here are like the 6 options you get to choose from for T, not T, H, not H, F, not F. So now we have to reference this. We have to we need 2 input AND gates to multiply these 3 variables together. So TTL, same for LS, 08, 2 input AND. N is available in the classroom. We need an A gate and a B gate. First thing we're going to multiply together is not T and H. Not T is this one, after the inverter. H, positive H is this one. Those two then have to get multiplied by positive F, which I think is this one. Then we repeat the process for T, not H, positive F. So you're going to have to place 2 more AND gates. Let's use the C gate and the D gate from the same chip. Close. So T, not H. T is the far left. Not H is in the middle, but right here. Because it's H, but it's getting inverted. And then this has to get multiplied with positive F. Positive T and H have to get multiplied. So that is 2 more AND gate, or a 2 input AND on a new chip, placed right here. And then we have to AND it with the third thing. So let's see how that looks. Positive T, positive H. This has to get ANDed with negative F, or not F, which is this one. Then if you need more bus line room, you pull these down. So we're creating the same thing for the last one. THF, TTL. Oh, there we go. TTL for LS 08. Let's use the C gate from the second AND chip. Oh my goodness. Positive T, positive H. These two also have to get multiplied by positive F. All right, so here's our reference right here, right? Let's just leave it up here. Plus sign is OR. So you have to add these two, and then add these two, and then OR them all together at the end. So that requires 3 OR gates. Write your part numbers. 32 is an OR. Put one here. It's going to look like March Madness bracketology. This one has to get ORed with this one. These get ORed over here. Man, that looks janky. And then the final indicator is going to be a red probe for the alarm to trigger when the correct sensors are properly indicating for Aunt Mary that the air quality is not good. So let's flip all three switches, FHT. In this configuration, right is off. It is 0. Okay, so when you finalize this logic circuit, you want to flip all the switches to the right where they're all on the ground, which is 0 for that switch. Now you can simulate this. 0, 0, 0. The light should be off. 0, 0, 1. The lights should still be off. You could reference your truth table. Also, when the switches are in 0, 0, 1, 0, the alert light is still off. When the switches are at 0, 1, 1, the alert signal triggers. The next combination is 1, 0, 0. The alert light is still off. 1, 0, 1. The alert is signaling on. 1, 1, 0. You could reference the truth table. The alert light is on. And then 1, 1, 1. The alert signal is still on. So this is the multisim of our air temperature, humidity, particle density alert system. After the multisim is accurate, for all 8 combinations of the T, H, and F sensors, then you could try and physically circuit this. You could draw this out on a piece of paper as well, and then label your pin numbers. This would be 1 input inverter, 2 on the output, 3 on the input, 4 on the output, 5 on the input, 6 on the output. These switches would be S0, S1, S2. I know they're labeled backwards here, but physically we would go S0, S1, S2. Then on the AND gates, I would just do this on order. These 4 AND gates are on one chip. 1 and 2 are inputs, 3 is the output. 3 feeds into 4. 5, 6 is the output. 10, 9, 8. 8 would feed into 13. 12, 11 is the output. Second chip. 1 and 2 is input, 3 is the output. 3 feeds into 4. This comes from 5 as input, 6 is the output. 10, 9, 8. 8 could feed into 13. 12 is the last input. 11 is the output. These feed into these OR gates on one OR chip because there's 4 gates in one chip. 1 and 2 are inputs. 3 is the output. 4 and 5 are inputs. 6 is the output. And then I like using 10, 9, 8 is the output. This should go to a red LED. You can actually rename these if you want. Label red 1. Oh, of course. So 3 switches, 3 inverter gates, 1 chip. 8 AND gates, 2 chips. 3 OR gates, 1 OR chip. And then we're going to use the 1 red LED to physically circuit our digital logic circuit that monitors conditions in a room in a house. T temperature, H humidity, F particle density. The red LED is the alert. Thanks.